Hello, this is Paul from Tech. In this video, let's prove Theorem 5.1.4, Eigenvalue and Invertibility. We do have a relationship between these two terms. Okay, and the theorem says a square matrix A is invertible, equivalent to lambda equals 0 is not eigenvalue. That's a good result. Very simple, right? Let's see why. Let me start from lambda equals 0 is not the eigenvalue, and then we find the equivalent statements one by one, step by step. I need the size of A. Let me say the size is n by n. A is a square matrix. Okay, n is the size. So how many rows or how many columns in A? We just learned, see, and the previous theorem. So I can find the determinant of A should be not 0. Okay, so look at it. I start from the characteristic polynomial, which is determinant of lambda I minus A. But here lambda is 0. Okay, so I put the 0 inside, and therefore this equals determinant of negative A, right? Negative A means we have n row or the negative. I can factor out the negative 1. Therefore, we have negative 1 raised to nth power. Okay, so a lot of negative 1 does not matter. Okay, so times determinant of A, and this is not 0. Okay, I would say why is not 0? If this equals 0, therefore 0 is a solution of the characteristic equation, right? But 0 is not the eigenvalue, therefore this should be not a 0. And you can back to look at the theorem 5.1.3. Okay. Negative 1, okay, whatever this is, either negative 1 or 1 times the determinant of A is not 0 means determinant of A is not a 0, right? Therefore, this equivalent to is not 0. Okay, now we definitely have, okay, by equivalent. If determinant is not 0, then invertible, right? So, okay, A is invertible because determinant is not 0. You see, it says if A is invertible, equivalent to lambda equals 0 is not eigenvalue. So that's the proof. Let me give you a remark. Okay, so this result just to say I took this as the opposite. Therefore, the opposite of invertible is singular. So I can make another remark. Okay, so lambda equals 0 is eigenvalue of matrix A, and then equivalent to is the opposite of invertible, which is singular. Okay, so that's the same. That's all for this theorem. Thank you.